as a main case study here, the Trimble Westminster building, I was highly involved in getting this project for JE done, and then it was the on-site technology manager as well. So what we did on the Westminster building is this was actually Trimble's strategic initiative here to grow their Colorado operations. It houses quite a few of their different departments, including machine control, Trimble buildings, the geospatial, which was formerly surveying, the MEP, monitoring, quite a few others, and R&D. Trimble actually leases over 40 buildings across the U.S., but this was their first building that they helped to design, build, and own and operate. So now they've been in the building since, I think, approximately May of 2013, and we were able to showcase quite a few of the technologies and capture some of the processes and metrics involved with this project and share those along with quite a few of the other projects we've worked on across the country and across the world. So phase one of this project actually consisted of approximately 125,000 square foot office building on a 15-acre site. And it's located in Westminster, Colorado, which is approximately 15 minutes from downtown Denver and 10 minutes from Boulder, Colorado. There's a nice little airport right actually at the top of this picture, right behind those buildings, and the Trimble office building that they're leasing during the construction of this project was right across the street. So for contractors in the audience, that was a blessing and a curse, but we learned a lot. We were definitely on our best game here since we were under the microscope. So this main image that we have on the screen here is actually from a helicopter. One of the plumbers was taking the helicopter license, helicopter lessons here from the airport right behind the photo, and he would fly over periodically and take photos for us. Kind of the funny story behind this is when I saw that photo on the superintendent's desk, I actually thought it was a very well rendered SketchUp model. So it's funny how close the model world is getting to reality nowadays. So as far as logistics and site layout, we actually went out there before we even had full construction models or documents, and we were able to lay out all 10 of the property corners. This is kind of an odd-shaped site, but we took the early civil design drawings, found 2 of the property corners out there, and actually took the total station and went and laid out all the various property corners. We actually found a few that were buried under a foot of soil because it had been a while since they actually established the property corners originally. We also found that the golf course, which is over on the west-hand side there, the right-hand side, had actually put a fence onto the property. So we were able to put pins at every 50 foot along the property lines, walk the superintendent and the manager of the golf course out there to show them exactly where the property line was, and we removed their fence without having any issues or any lawsuits later. We also used the total station to lay out our stockpiles, our laydown areas, our construction trailers to make sure we didn't have to move them later when we started installing utilities and light pole bases and other items out there. And we were able to lay down the stockpiles so that they didn't interfere with any of the utilities or other excavation processes out there. Something we would use it for on other projects are to lay out stormwater management. That is now a big issue on a lot of projects, and to lay out any of your larger mock-ups that are required by the architects or engineers. So site work, surfaces improvements. We actually laid out quite a few of the building pads and the over-excavations for our earth workers. Subsurfaces, we had over-excavation requirements for the foundations out here that we were able to verify with the total station and our X, Y, and Z coordinates. We were also able to lay out some of the subsurface for the parking lots, some of the curb and gutter requirements to make sure we get the light poles in the right locations, and to double-check sidewalks and landscaping equipment and landscaping lines. So one of the lessons learned on this project was that a lot of times when you get a model or a drawing of your light pole bases, that you'll want to establish a certain distance off the top back of the curb. So a lot of times the engineers will draw the light poles and they won't necessarily have them positioned exactly where you want them. So what we did on this project was establish a 3-foot to the center of the light poles off the top back of curb to make sure everything was consistent along the sidewalks and curb lines. We did use Trimble machine control out on this project. We utilized the TNSS receivers and the SBS 900 system out here. But you're actually also able to control your large equipment with a total station through machine control. So you have mag drives and multi-track systems, which will actually allow the robotic total station will actually move on a system of magnetic, almost like gears, basically, instead of gears. And so this way, you don't have any gears that could grind or have to repair later or stop mid-gear when you're trying to take a precise measurement or track moving equipment. The multi-track system will actually allow you to track and lock onto passive or active prisms, and we highly recommend going with an active prism. Trimble has an MT1000 product that has 8 separate channels. You can actually have 8 of the exact same Trimble robotic total stations on the same site, each tracking their own individual layout person without having any interference from reflective safety vests or layout prisms or other reflective surfaces like headlights or anything like that from vehicles passing by. The really cool thing about this project is we were able to get the building pad to 1/8 of an inch of the actual design location. And this was with a 6-foot over excavation as well. And the excavator out here was able to complete their whole process substantially faster. I think they saved about 4 weeks from the original anticipated dirt work moving process that was in the original schedule. Utilities. There are quite a few temporary utilities that go into a project, especially when you have on-site construction trailers. We're actually able to track where the temporary electrical, where the gas lines are installed, some of the temporary plumbing, and then even the low voltage for telephone systems and internet connection. We were able to track that information and put it within our model so that we knew where they were throughout the entire process of construction. We're actually able to go out and lay out and as-built the permanent utilities and some of the irrigation systems as well in this project. So one of the lessons learned, and I'm sure a lot of people who have been on construction projects will know, it seems like if you have any low bury systems such as electrical or gas, that a lot of times those will get trenched through no matter how well you lay them out. So something I'd recommend is to lay those out on a monthly basis and clearly demark them, even as close as 20 feet on center, so that you can try to keep people from trenching through them when they're running electrical or irrigation lines. So the foundation is the concrete. We didn't have any CMU on this project, but a similar process could be used for your CMU and your rebar dowels that go into each of the cores. Our single layout foreman out here, he was able to use the Trimble robotic total station to lay out each of the 83 piers out here. And we actually put 4 offsets for each pier. We actually marked each of those piers with lath and labeled the elevations, the cut and fill requirements, the type of pier, and the rebar cage that was going to go into each pier so that there weren't any questions when the guys were out on site. We also used 60 penny nails with whiskers at each of the concrete foundation corners and the pier cap corners. And we even installed points where there's going to be door blockouts or changes in the brick ledges, also that the folks that were installing the formwork would know if there was a change coming up. They could understand that and see that on the ground before they even start putting up formwork. We actually put in every corner of the structural concrete cores on the foundations. We marked that with markers on the ground. We even put in the door openings so that the rebar installers would know that they needed an exact 1.5-inch clearance before the formwork was placed. We were able to get 100% accuracy and get every embed and anchor bolt on the project, and we had all the anchor bolts within a 1/16 of an inch for the entire project. So on future projects, some things we've seen people using The total station 4 is to mark out post-tensioning cables so that you don't have to core or X-ray for those cables later if you're trying to move walls or remodel the project. And some of the lessons learned is definitely need to watch the heat. Changes in temperature during a day will dramatically change your formwork location. Also, on the cores, we'd make sure that the workers would go out and check the diagonals on the cores before we'd run up there with the total station, just to make sure that they actually had the core formed up square before we got there. Also, something we've seen on some other projects is shrinkage in concrete, especially on post-tensioning decks. So a lot of times on these high-paced projects, they will set out control points on concrete that is only a day or two old, and the concrete can actually shrink over time, and that point can move by as much as a half an inch. Or if you're going in and tensioning post-tension concrete decks, you can actually get the concrete to shrink significantly as well. So another half an inch, which would change your entire location of the building pretty substantially. We spent quite a bit of time on this project laying out all the steel, the structural steel, and the edge angles. We set out grid lines at every anchor bolt. We set out elevations and benchmarks at each of the cores and at each floor. So this allowed for the quick installation of permanent stairs in steel structure prior to the actual decking installation. And this saved a lot of time in building temporary job site ladders or trying to access the project on various floors and having to pull all your equipment and materials up with a rope. The steel worker actually was able to install all their steel basically twice as fast as they had originally scheduled. So each of the lots on this project they had scheduled for approximately 2 weeks for installation, and they were able to set almost all the steel within 4.5 days. So that allowed them to go back and double check all their installations, put in some of their bracings, and do a lot of the safety rails and stuff like that that usually gets pushed off until after they're wrapped up and everybody's trying to get on the deck. We actually reduced the structural RFIs by at least 50% on this project compared to other projects. And like I said before, we got all the anchor bolts and embeds installed with 100% accuracy. We actually went out and actually checked all the edge angle along the perimeter of the building and at openings, and we did find some issues that were created with just bad tape measures, or actually bad tape measurements. So we got those issues corrected, and some of the lessons learned on this project were obviously the expansion will affect the steel structure dramatically. That steel structure will actually follow the sun and be affected by your concrete boards or how you brace the building and or how you get the deck installed. Also, watch for late changes or submittals on MEP and other related items. I think we had to add a couple of embeds at the very end of this project to account for changes on some of the mechanical equipment. Luckily, they were small ones that could be drilled and bolted, but that is something that will affect projects as these things are getting moved faster and faster. And then one of the major items that I've been preaching to at a lot of projects now is to go and check the pre- and post-pour camber. A lot of steel structures will have a curve in each of the beams to account for the loading of the decks. When you pour your concrete, that beam should actually come out to relatively flat. So on this project, a lot of our beams had a 2-inch camber on them, and by the time we got done pouring the concrete deck, we actually lost an additional 2 inches on a lot of these beams. So that doesn't sound like a big deal for a lot of projects, but when you're going through the whole process of 3D MEP coordination and you're moving all your MEP systems to within 1/8 of an inch, if you lose 2 inches in your ceiling height, it affects all the systems substantially. So luckily we were able to catch this issue early in the project and move some of the systems around so we didn't have major changes in the ceiling heights anywhere. One of the products that was introduced while we were in the process of this building was Trimble Vision. And so we didn't have it when we first started on the project, but we tried to incorporate it later in the steel process. And Trimble Vision basically allows you to remotely see and control the total station through a live video feed through the instrument. So it basically allows for augmented reality layout. You can have a 3D model overlaid on the actual view of the project, and you can control the total station from several hundred feet away and see all the points right around you. So we were actually able to use that technology to track some of the final steel columns that were put in place on this project. And we got the steel within a quarter inch of where the model actually said it should be. So even tighter than the AISC specifications. Exterior layout and prefabrication. The structural exterior framing on this project was actually designed within Tekla Structures. And we're able to use that model to lay out offset lines and center points of these panels so that they could build all the panels down on the ground in pre-made jigs. So since we were able to complete all the curb and gutter and the parking lots early in this project, the framing subcontractor was able to create their jigs on the site and prefab all these exterior panels. So not only does this save a lot of time in the actual installation process, but increased safety dramatically since you didn't have folks out on lifts trying to individually stick frame each of these little pieces all over the entire building, let alone all the falling debris and the clutter that create. The glazing subcontractor was also able to prefabricate all their panel and window systems so that we were able to install that basically weather protection early in the project and save a lot of temporary weather protection. Here in Colorado it gets pretty cold about November, and we have to provide heat for the workers to stay productive. MEP layout and pre-concrete pours. A lot of superintendents, and I'm as guilty as some, but we get in a hurry to pour concrete floors because it shows production. It's literally something in concrete that you can prove that you've done something at this point. But we try to tell a lot of folks is that you need to wait until you get the entire MEP process coordinated, because it'll save a tremendous amount of time to be able to lay out your hangers, your duct straps, sleeves, anchors, lockouts, even your penetrations on the deck pre-pour. It'll save a lot of time when you're trying to go through there and lay all that information on the floor above your head, then bring a lift and drill lots of ladders or so forth, and create major safety issues, not to mention major inefficiencies. Also on this project, we were able to prefabricate the boiler room that went up onto the roof of this project. So our subcontractor was able to lay out all that information in their temperature-controlled warehouse, build the entire boiler room there, put it on a skid, and then lift that skid into place under the roof with a crane. And that you can imagine how much time that would take to get all your welding equipment up there, all your parts and pieces, break it down every day, and get it laid out correctly up on the roof. So that saved them a tremendous amount of time, and it's a very efficient process. So we did end up doing a interior layout competition on this project. I've heard from a lot of folks that there's no way that you can use a robotic total station to lay out interior walls faster than what you can do with a tape measure. And with this project being pretty basic in its layout, very straight walls, everything is based upon a grid line. We had concrete cores to measure it off of and control points all over the place. I was a little concerned that we may get beat on an interior layout competition, but we went ahead with it, and obviously the robot did not win the coin toss, but the framers chose their side, and they took the left-hand side of the project and basically laid out 100 points in the same time that we were able to lay out 200 points for the robotic total station. So we basically doubled their efficiency. Not to mention the fact that there were quite a few dimensions that they didn't have on the drawings. So they were missing dimensions for openings, for some door locations, for column chases, and MEP chases. And they actually made some mistakes on laying out some of the areas that were supposed to be typical and planned. So they actually laid them out in the mirror fashion of where they should have been, which would have created some major issues when we got into casework. So on the interior framing, we laid out all the interior priority walls first on the project. So this allowed a lot of the critical ductwork and MEP installations to go in early. This is especially important when you get into firewall locations, hospitals, labs, or other sensitive building projects where the walls need to be sheetrock and sealed from the floor all the way to the structure above for fire safety or infection control or negative air issues. So we were able to frame, drywall, firecock, and inspect those areas before we got them covered up by the large ductwork and other piping that was in the way down the main corridors and so forth. Now, as our drywaller didn't have an internal bin person or total station layout, Jay Dunn actually modeled all of the interior walls showing individual studs at the correct fire rating. So we showed the exact wall thickness, and we laid out all the interior walls of the actual track line, including every door, every window opening, the interior and exterior wall corners, the column surrounds, MEP chases. There's actually some curvilinear soffits within the project, and even the skylights. We actually even took it all the way down to the fire extinguisher cabinets, because I've had numerous projects where we get down to the end of the project and fire extinguisher cabinets didn't get installed, so we'll cut a hole into the wall and find sorts of mechanical or electrical piping behind the location where we wanted to run that fire extinguisher cabinet. So now, instead of being able to complete your punch list early, you're going through and cutting holes in brand new sheetrock and painted walls and kind of making a mess of your project. So we went and laid out even down to the fire extinguisher cabinets to show where those went. Some of the new developments that Trimble has come up with for the Trimble Field Link, which is one of the controllers you can use for a robotic total station, is the Surfaces module. And so with the Surfaces module, you're actually able to utilize your robotic total station almost like a scanner system. So you can program the robotic total station, take a shot on the slab or the ground at a certain interval, 6 inches on center or 2 feet on center, using the direct reflex scanning mode. And so that's basically providing a laser beam so that you can take measurements on even vertical surfaces or difficult to reach areas without a prism. And so you can control this function through the scope of the robotic total station or through the controller remotely. And basically you can provide all the information you'd need to figure out if you have sills or cuts in any of your floor slabs. So you can check the elevations against a benchmark or against your model. You can create contour lines where you need to fill or float the floors, or if you need to grind the floors. And this becomes especially important for hospitals where you have large areas of vinyl sheet flooring, or in warehouses or other facilities requiring super flat floors for equipment or robotics. Another new development is the interior plan module. So again, you can use your robotic total station as a pseudo laser scanner. You could set it up in an open space where maybe you don't have existing 2D drawings or other documentation yet. And you can take up to 400 individual points at the level of the total station and create a 2D drawing, basically, from individual points along the interior space or exterior space. And then you can also take specific shots for door frames or window openings or specific corners that you want to catch, and actually create almost a 2D drawing just from your individual robotic total station shots. So as far as quality control and assurance, I'm a big proponent of using the robotic total station to ensure that your project actually got installed, to make sure everything got installed where you said it should have been, either from the 2D drawings or from your 3D model. So one of my old superintendents used to tell me that you need to inspect what you expect, and this is a clear use case for the robotic total station, that you're out there. Every individual installation needs to be laid out somehow, either with a tape measure or a mechanical total station. But the robotic total station gives you a lot of benefits by being able to do the entire process basically twice as fast as normal, And then you're actually able to take field reports and get daily layout summaries, your deviation reports. You can get field reports with photos and exact coordinates for any issues you may have on the project, and take those back into your project management software, such as Prolog or into VCO, to understand where your issues are going to affect other installations. So you're able to check and control logistics, site work, utilities, concrete, and steel, not only pre-pour, but during and after the pours, to make sure everything was installed correctly. We also did quite a bit of quality control on the Westminster project by checking the installations that were supposed to be within the stud wall cavities. So your MEP stub-ups that have come up through your slab on grade or through your deck penetrations, we went back and double-checked those before pours to make sure that the penetrations are actually within the stud wall cavity, and we wouldn't have to have issues framing out chases or moving things around after the concrete was in place. Also, by going through this entire process, you're able to guarantee dimensions, so it allows for prefabrication, not only of bathrooms and boiler room assemblies, but your exterior panels, your glazing, even down to your casework. So, especially on projects such as hospitals or schools or hotels or that type of assemblies where you have a lot of casework going in, there's usually issues where you have electrical that are supposed to go above counters or fire alarm systems or those types of systems that usually get stuck behind a cabinet because nobody realized that the cabinets were going to be installed in that location. So now you're able to not only lay out your interior partitions, but lay out your casework at the exact same time before you get going into construction. So some of the productivity enhancements and metrics that we saw just on the Westminster project alone, and we've repeated these metrics on several other projects, is that we were able to complete the entire excavation process 4 weeks faster than we originally projected with the civil grade control systems. The structural steel shop drawing, we used a in-model review system within Tekla Structures, and we were able to reduce that by 33%. We had 100% embed placement, 50% reduction in structural RFIs. We actually had a 200% increase in efficiency with the actual steel erection itself. We were able to check final columns and make sure that they were within a 1/4 inch of the actual model location. And on future projects, especially these really complicated steel structures, you can use your DR mode on the total station to double check those steel columns and make sure they're all going to be within your tolerances expected as well. With the MEP, we were able to install all the hangers and blockouts and so forth 4 to 5 weeks faster than they had anticipated, and they also saw up to 400% increases in their installation speeds over their traditional methods. So that actually led to 30% reduction in the MEP-related RFIs and so forth. So why would this matter for a general contractor or an owner or a subcontractor? I've actually heard recently from folks involved in the bonding of projects that they believe that a contractor benefits more from an MEP or from a BIM and total station process more than actual safety, because a safety incident is actually a one-time incident, whereas the quality and possible lawsuits involved with a late project or a poorly performed project will last the entire length of that project. So it actually reduced costs quite a bit as well, since you have less RFIs, you have less redesigns, and less general conditions later if the project ends up going over. The shorter schedules all come from having a reduced submittal and permit review time. You can actually go with your just-in-time delivery, which reduces clutter on the job site, and you actually can get to your punch list completion faster and have it done more accurately and get the owner in the space faster than originally anticipated. So this should all lead to a better quality project with less leaks, better structure, and better MEP that's actually within your stud wall cavities, and hopefully less lawsuits and increase the relationships on the project to make everybody get along better, since there's a better quality project at the end. And with owners, they only spend typically 20% of the entire building life cycle during the construction process. The other 80% of their building's cost comes during the facilities and maintenance of the project. So if we're able to give them real-time and accurate as-builds, they're able to make better decisions on how they want to remodel a project and more informed decisions later.